Hello boys and girls, this is Mr. Kizik, and in this video we're going to be talking about imaginary numbers. So what is an imaginary number? It's when an equation such as this here, x squared plus 1 equals 0, would have no real solutions, because if I subtract 1 from both sides, I would get x squared equals negative 1, and in reality I cannot take the square root of a negative number. If I try to do that in a calculator and I put square root of negative, again, 1 in this case here, your calculator is going to say error, non-real answer. Now, that's not to say that imaginary numbers are not real. They are real, and they are found in the real world. A general thing, basically, where they are found is in electrical engineering. Now, what does that entail? Well, basically anything that you plug into your wall outlet uses electrical engineering, uses currents, and that uses imaginary numbers. Likewise, if you listen to the radio, the airwaves that the radio stations are using uses imaginary numbers, and those cell phones that you use too to get the signals also use imaginary numbers. I could go into more detail about it and talk about how imaginary numbers came about, but what I think you guys should do is go to YouTube and look for the real world uses of imaginary numbers by this person right here, and then just watch the video. It's pretty interesting. If you have some basic algebra 2 knowledge, you'll understand what he is talking about in the video. If you're really more just interested about the application for it, which again, I understand, not everything you do is going to pertain to you exactly, but it does pertain to the real world. I believe it's around marker 940 that you can go to and just see how it is applied in electrical engineering. Alright, so back to the math here. So imaginary numbers have a couple components here. There's the imaginary unit, which we call I, and is defined as the square root of negative 1. There's also another portion that I could talk about here. It's called a pure imaginary number, which is written in the form of bi, where b, or we can say the coefficient, is a real number and I is the imaginary part. So if we look at the steps to how to simplify negative square roots, the first step says rewrite square root of negative a as negative 1 times a. What we're going to do, remember the property of radicals where I can, if I'm multiplying two radicals, I can just multiply what's inside the radicals together to get one big radical. I can break it apart like this. Square root of negative 1 times the square root of a. Because again, the property says I could do negative 1 times a and get negative a. Step 2 then is to break down the square root of a, just like what we did last class, and then don't forget you did factor out a square root of negative 1, so you got to put an I at the end. So let's look at a couple problems here. So number 1, square root of negative 9, I need to get rid of that negative sign in it. So I'm going to factor out a negative 1. Well, now I just simplify the radical here. What is the square root of 9? Oh, it's 3. Don't forget it will be plus or minus 3. But because I did factor out square root of negative 1, I got to represent that somehow. I don't rewrite square root of negative 1. I represent it as I. And that'll be your answer. Okay, so let's look at number 2. I got the square root of 96. Again, factor out a square root of negative 1. And then simplify square root of 196. Well, square root of 196 is 14. Plus or minus 14. But then, since I factor out square root of negative 1, there's an I at the end. Let's look at number 3. Square root of negative 5. Again, I'm factoring now square root of negative 1. So now I have the square root of 5. Turns out square root of 5 is simplified, so I would have square root of 5 and then the I in front here. Alright, one more look at. So square root of negative 80 is the same as writing square root of negative 1 times the square root of 80. Now square root of 80 can be simplified here. And remember, I'm going to look at what's my biggest perfect square that goes into 80. So you got to remember your perfect squares, and you remember you start with the one that's right smallest. So that would be, 8 times 8, 64 would be the first one to try. No, 64 doesn't go into 80. Try 49. No, that doesn't work. 36 doesn't work. 25 doesn't work. 16, pretty sure does not work either. Sorry. 16. Oh, it does work. Well, you know. Mental math, not my cup of tea today. So, yeah, so it would be the square root of 16 and the square root of 5. So then the square root of 16 would be 4, and I got square root of 5. But because I did factor out square root of negative 1, I would put an I in there. Now, if you put the I out front here, fine. Don't worry about it. But the standard way of doing it would be... Let me just rewrite this. The standard way of doing it would be to put it right in front of the radical. Oh, and don't forget your plus minus. Okay. So that's how you would do just pure negative square roots. So just like what we did before last class with solving equations, I can do that here. So you're still following the same steps. You gain the x squared by itself and then solving for x. So here I would subtract 81 from both sides. I get x squared equals negative 81. Take the square root of both sides. Well, in this case here, I got to factor out square root of negative 1. I got the square root of 81. And then we know the square root of 81, that's a perfect square, so that's 9. So I would have x equals plus or minus 9. And don't forget the I, because I factor out a square root of negative 1. Alright, let's do another one here, 9. I got to subtract 15 from both sides. I got 4x squared equals negative 24. Divide by 4. X squared equals negative 6. And take the square root of both sides. So in this case here, let's factor out a negative 1. Square root of 6 is already simplified. So x is going to equal plus or minus I square root 6. Okay, let's look at another example here. Come on, refresh. Refresh. There you go. Alright, so what I'm going to do here, number 11, I'm going to add 5 to both sides. Add 5. So I'm going to get 3x squared equals negative 441. And then I'm going to divide by 3. Now I'm going to get x squared equals, let's do that, 441 divided by 3, is going to be negative 147. And then I'm going to take the square root of both sides. So because I'm taking the square root of both sides here, and my number inside my radical is a negative, I got to factor out a square root of negative 1 to make it positive. And now what I got to do here is simplify the radical. Again, check to see is 147 a perfect square. It is not. So then I got to go through my list here and determine what can be divisible into 147. What's the biggest perfect square that can go into it? So I would probably start, you go with the perfect square that's just smallest of 147, which is 12 times 12 or 144, and then divide. So it's not going to be 144 not going to be 121, not going to be 100, not going to be 81, not going to be 64. Is it going to be 49? Yeah, it's going to be 49. 49 and 3. And then what does 49 and 3 break down to? Let me just continue up here. 7 square root of 3. But don't forget, we did factor out square root of negative 1. So it's 7i square root of 3, plus or minus. Right? So that's how you solve problems when I have the square root of a negative number. Let's look at the powers of I here. So what we said before, I to the first, or just I, which is just I, is equal to the square root of negative 1. Okay. I squared, as you know, is I times I. But what is I already? It's the square root of negative 1 times the square root of negative 1, which is just negative 1. What's I cubed? Well, wouldn't you say I can rewrite I cubed as I to the second times I? Right, because remember the properties of exponents, when I have the same base, which in this case here is I can add the exponents. Well, isn't that the same thing? Let me just rewrite this. So I cubed is I squared times I, which is the same thing as what we just said before, is negative 1 times, we'll just say I, which is negative I. Then I to the fourth is the same thing as saying I squared times I squared, which is the same thing as negative 1 times negative 1, which is just 1. Now if we go to I to the fifth, that's the same thing as saying I to the fourth times I. Well, what is I to the fourth? We just said that was 1. And I is just I. So what's 1 times I? I. In fact, let me rewrite this over here. Should have been clear over here. This should be I to 1. That's what we said it is, so that's just I. Okay. Yeah, so I to the fifth is just I. Well, what's I to the sixth? Well, couldn't I rewrite I to the sixth as I to the fourth times I squared? Which, if we look over here, is just equal to 1 times negative 1, which is negative 1. And can't we rewrite I to the seventh as I to the fourth times I cubed, which we just said was 1 times negative I, which is negative I? And can't we rewrite I to the eighth as I to the fourth times I to the fourth, which equals 1 times 1, which is 1? If you notice here, the pattern is the same every 4 times here. So if I did I to the ninth, it would be I. If I did I to the sixth, it would simplify to negative 1. I to the 10th, I to the 11th, sorry, would be negative I. And I to the 12th would be 1. And then the pattern would go over again. So how does this pattern help us? Well, if I look at number 13 here, we've got I to the 15th. I could do this pattern all over, or I could do a little trick here. Since the powers of I here, there's a pattern every 4 times here, I'm going to divide that exponent by 4. Okay, so what's 15 divided by 4? We'll do some elementary math here. 15 divided by 4, some long division. 3 goes into it, 12 with a remainder of 3. So what does that mean here if I got a remainder of 3? That means, excuse me, that means then it would follow that pattern right there. So I to the 15th is the same thing as I to the 3rd, which is negative I. So these powers here help you. I to the 1. If the remainder is 1, it's I. When I divide the exponent here, if the remainder is 2, it's negative 1. If the remainder is 3 of the exponent, it's negative I. If there is no remainder, if it's a multiple of 4, then my answer is 1. So let's look at 14 here. I to the 62nd power. Now, going to take 62 and divide it by 4. And I get, let's see, 422, 522. So I got my remainder of 2 here, which means this, I to the 62nd power, is the same thing as I squared, which is negative 1. Right. So let's look at some products of pure imaginary numbers here. So you're going to treat them like you would with a variable. You're just going to multiply it out and then simplify the powers of I here. Because as you can see, when I simplify I, there's never any power. It's just I, negative 1, negative I, or 1. So if I look at number 15, 4I times 7I. Again, just pretend they are variables terms. What's 4 times 7? 28. What's I times I? I squared. But what we say I squared was before? It was negative 1. So 28 times negative 1 is negative 28. All right. Let's look at number 17 here. Now number 17, we have 2I cubed times 5I. Well, 2I cubed, what's 2 cubed? 8. And I cubed is I cubed. So times 5I. So now just do the math. 8 times 5 is 40. And I cubed times I is I to the 4th. But from our pattern, what does I to the 4th represent? It represents 1. So 40 times 1 gives me 40. One more we will look at together. So number 19. Now normally with square roots, you would just multiply what's inside. The two numbers multiply together. But remember, these are imaginary numbers. Technically, this doesn't exist. Square root of negative 18 is invalid. Square root of negative 10 is invalid. So in this case here, we've got to make it valid first before we even multiply anything together. So I got to simplify square root of negative 18, which is the square root of negative 1, and then the square root of 18. Square root of 18 simplifies to square root of 9, square root of 2, and then this would be 3 square root 2, but because we factor out a negative 1, there's an I. Same thing here for the square root of negative 10. Square root of negative 10, have to factor out a negative 1. And in this case here, there is no perfect square that goes evenly to square root 10. So this just simplifies to I square root 10. Square root 10, sorry. I don't know why I wrote 2. So now my problem becomes this. It's not the square root of negative 18 times the square root of negative 10. The problem now becomes, I'm going to write to the side here, 3I square root 2 times I square root 10. And now I can multiply it because it makes sense here. It's valid. So now what I can do is I multiply everything that's on the outside of my radical. So 3I times I, 3I squared. And then the square root of 2 times the square root of 20 square root of 10, sorry, is the square root of 20. Well, hey, guess what? I have to simplify this still. Square root of 20 breaks down into square root of 4, square root of 5, which is 2 root 5. So now the outside becomes 6i square root of 5. Right there. 6i squared square root of 5. But hey, we can't have a square with my imaginary numbers here, with my pure imaginary number. What does I squared represent? 1. So luckily for us, nothing changes, just basically gets rid of it. And we're left with 6 square root of 5. And to me, that's pretty interesting there, that I was able to start with something that really doesn't exist, and I got a real answer. So to me, that's pretty cool. Alright, so that's how you do pure imaginary numbers here, and how you simplify negative square roots. So for homework, what I want you to do is, I would like you to do the odds, front and back here. The roots of the quadratic equation I could represent. Okay, you can skip 21 and 23 here though. But the rest of it here, I want you to do the odds. All right, so I'm just going to write it here. Odds. All right, so just do the odds. If you got questions or concerns, please feel free to email me or message me. All right. Hopefully this video helped you, and good luck with your homework. This is Mr. Kizek signing off.